Now that we've been introduced to functions of multiple variables, it seems natural that we would want to think about graphing them. But we have some function that has two inputs and it has one output. So if you think about it, those are kind of like having three variables. Not really the variable, but sort of like independent and dependent variables. So if we have some sort of two variable function f of x, y, and we think of its output kind of like a variable, then we can say that z equals f of x, y, where this is the dependent variable and x and y are independent variables. So what that does is allows us to create ordered triplets of input x, input y, output z. And those ordered triplets can be plotted on a graph so we can visualize how, as the function moves around in x and y space, how the output of that function moves around. So an example of that would be this function, f of xy equals the square root of x squared plus y squared. And one thing we can do is construct what we think of, or what is called a level curve. And a level curve is this idea of you set a fixed output value and you let that output value, you plot that in a 2D realm. You plot the inputs that would give you the same, you plot all the inputs that would give you the same output value. So let me explain. If I say z equals 1, what I'm really saying is give me all the outputs for which this equation holds, which is, 1 equals x squared plus y squared. So then what I can do is I can say, well, that's a circle of radius 1. So if I have z equals 1, I know that the x and y values are all in that ring. So if I came over here and was trying to do the same thing, I could say when z is 1, I have a little ring here of radius 1. I could do the same thing with z equals 2. So that tells me that that's actually a circle of radius 2. So I come up here and I say, okay, well, when z is equal to 2, it's a circle of radius 2. And what you'd find similarly is when z equals 3, that's a circle of radius 3. And what you'll find is that the graph of this particular two-dimensional, or this sort of two-dimensional function, but it's graph with its output included, so it's a three-dimensional graph, shows that as x and y scale out, it scales like a cone. And the outputs, so the outputs as x and y grow larger, the output of z grows even larger, which is what you might have expected just from looking at this. But it's always helpful to visualize this because sometimes you have visualizations that are incredibly more complex than a cone, and you want to see how things are sort of riding the waves. You can kind of see crescendos and things as they go up, and you can easily spot, oh, that over there looks like that's where a local maximum is and such. And we'll learn some techniques on how to do that analytically. But a graph is always very informative to understand intuitive behavior.